So for section 1.8, we're going to be simplifying expressions. But to do that, we need to know what like terms are, because we can only combine like terms. So let's go ahead and start with some that we have. I have a 9t here, and I have a bunch of options here on the left. So take a second to write those down. And what would be a like term? Well, I have it defined down here. It's where we have the same variables, so same letters, with the same exponents. So if I got a 9t, I'm looking through here and I'm looking for another one with a t. I see it, 9t, and not the 9, right? That's not the variable. Has to have the same letters, so 6t. And 9t would be like terms. What else do we have? 6x squared. Do we have any x squareds in here? Right? Well, 6x squared and 6x squared are like terms. They technically have both the same. They have the same variable and the same number, right, coefficient. But they have to have the same power as well. So they can't just have, somebody's like, why not this 6x? Well, that's 6x. You need to have the same exponent. That x has to still be squared. Negative 2pq. I'm looking for a p and a q. I see 8pq. Same letters, same variable. I'm not worried about the coefficient. That's not what makes them like terms. They have to be the same letters. 3x squared y. Are there any x squared y's? See, here's a negative 7xy squared. Is that the same? See, it's not quite the same, is it? I need the x to be squared and the y to really be to the first power, not the x to the first and the y to the second. So really, I'm looking for this option right here, which was negative 7x squared y. And that means what we're left with are not my like terms. And so I'm going to make sure I go through, right? We said 9t and 6t were like terms, but 9t and 9x are not. Why are they unlike terms? They are not the same variable, right? X and t are not the same variable. 6x squared and 6x were not like terms. Why not? Even though they had the same coefficient, the same letter, it has to be the same exponent. That x has to be squared. See, this 6x squared really means 6 and 2 x's. This one just means 6 and 1x. Those are not the same. You don't have the same. This one has 2 x's. This one has 1. That makes them unlike. Negative 2pq is not the same thing as 9yz. Even though I have one variable, they must be the same letter. So kind of like the first example, just with more letters. And 3x squared y is not the same, or not like, negative 7xy squared. Even though it has to have the same, even though it has the same variables, an x and a y, they have to have the same exponent. This is really 2 x's and a y. And this one is negative 7, an x and 2 y's. The variables are not the same if the exponents are not the same on them. Okay? So that's kind of our big definition. And then we're going to look at, I think, just 5 examples, I think, of what we're going to do with them. When we have like terms and unlike terms, we can combine them. So 2m minus 3 plus 5. What are my like terms? Well, this right here has an m. Nothing else has an m. So I can't combine that with anything else. So my answer is just going to have that 2m. That 2m does not simplify. But negative 3 plus 5, those are like terms. Those are what we call constants. They have no variable. So therefore they are the same. Negative 3 plus 5 would cancel. 3 negatives with 5 positives, leaving us with 2 positives. And that would be simplified. See, this section really is a lot easier than some of the last sections. Look at this next one. 3x minus 2y. Can I combine those? They both have one variable, but they are not the same. So I can't combine them, so I can't simplify it. No, that's not true. We do know how to simplify this from the previous section. I can take that negative 5 now, and I can, what's the D word? Distribute. I can multiply that negative 5 across, and I get negative 5 times 3 is negative 15. X, negative 5 times negative 2, a negative times a negative, positive 10y, and that's it. I can't combine them any further, but I could simplify it by distributing. This next one, negative 3 minus 4p plus 7. I can't combine 4p plus 7. This one is a variable, this one is a constant. They don't have the same variable, same exponent. So what can I do? Well, I can take that negative and I can distribute it first. I like to think of it, and I'll write it down, but I like to think of that negative as a negative 1. So I'm going to bring the negative 3 down, and I'm going to distribute this negative 1 across the group. Negative 1 times 4 makes that p a negative 4p. Negative 1 times positive 7 makes that a negative 7. Now that I'm done distributing, can I combine anything? We can only combine like terms. What are my like terms? Well, these two are constants. When I write this, now technically we generally put the variable first, so I'm going to do that. I'm going to put the negative 4p. But you still got to remember your old rules. What is negative 3 minus 7? If you know that's negative 10, good, keep going. If you're not sure, remember we think of that as negative 3 plus negative 7. In fact, that's how I can get negative 10 in my mind, but this is still what I'm doing. In my mind, I'm changing it from a subtraction to an addition problem. And that would be it. Next one. Negative 2y plus 5y minus 9y. Okay, what are my like terms? Well, each and every one of these has a y, and they're all the same exponent, meaning I can combine them all. So I can combine all these things. What would I do? I think it's easier to combine the negative and the negative first. I could go from left to right, but I also know commutative property. I can change the order. Negative 2 minus 9 is the same thing as negative 2 plus negative 9, or negative 11y plus 5y. They are opposite signs now, so they cancel, leaving me with 6, but negative 6y. Almost there. I feel like this is more than 5, though. I might have, like I said, I may have lied to you. Negative 3x squared y plus 4xy squared. It's tempting. People will go, okay, yeah, they both got x's and y's, right? But do they have the same exponents? This x is squared, this x is not, this y is first, this y is second. These are not like terms. Which means what? We cannot combine them. So what's our answer? We would say that it is already simplified. Meaning anything we can do is already done. Or we could say, if you like the negative, it cannot be simplified further. I think the book uses the second statement. I try to stay away from negative statements here. So cannot be simplified further. This is kind of our culminating example. This is our last example. This is the hardest thing on the 1.8 homework, and it's not that hard, but I like how it puts together the stuff that we've done from the beginning of the chapter. So first of all, if I want to combine these cannot be combined. They are not like terms. These cannot be combined. They are not like terms. Mathematics would shut down at that point, except we can take these numbers and distribute to eliminate the grouping. We can eliminate the grouping by distributing. Okay, so negative 1 times 3 makes that a negative 3k squared. Negative 1 times 5 makes that a minus 5k. Positive 7 times k squared gives us positive 7k squared. Positive times a negative makes that minus 28k. Anything we can combine now? Are there any like terms? Yes. I can combine k squared with k squared. What is negative 3 plus 7? Well, 3 negatives, 7 positives cancel, leaving us with 4 of those k squareds. Negative 5k minus 28k are like terms. Negative 5 minus 28, in my mind, I'm thinking as an addition problem, where those negatives combine to give us negative 33k. Now, if I had a problem that had fractions at the end, I would need to make sure that I would simplify anything I can at the end, simplify those fractions. But that's it. That should be it for the end of the chapter. This is not the hardest section. There might be some hard questions, but great. Come in with those questions. Go to the Learning Center. Come see me. I'll be happy to work with you. Find some mentors. Find some tutors. Utilize the resources that this college has for you.